welcome to our class. So for today's lesson, we're going to talk about the greatest common factor, or the GCF. In this lesson, we will be finding the common factor of the given numbers and identifying the greatest common factor of given numbers using prime factorization and short division. But first, let's try to identify the vocabulary. What is a common factor? When we say common factor, it is a number that can be divided into two different numbers without leaving a remainder. Often numbers can share more than one common factor, and it is also possible to find the common factors of more than two numbers. And what about greatest common factor? When we say greatest common factor, that is the largest factor that two or more numbers have in common. Okay, so let's get started. But before that, when thinking about finding the greatest common factor, or the GCF, we can think backwards, okay? So first, F, find the factors. C, you're going to circle the common factors. And in G, you group the largest factor, okay? You can have F, C, G. That is the invert or the backwards of G, G, C, F, okay? Or if it's too hard for you, then we can remember for this just a simple thing, okay? You think it simply. We will have G for greatest, C for common, and F for factor, okay? This is called GCF, greatest common factor. Okay, so let's have an example, but okay. Now remember, in finding the greatest common factor, we can use two things, right? It's either we can use the prime factorization method, or we can have the short division. So let's try this example. Find the common factor and the GCF of 24 and 36. The first thing that we're going to do is we'll list down the factors of each number. Next, we're going to circle the common factors. We have 1, we have 2, 3, 4, 6, and then 12. Okay, so what are the common factors of 24 and 36? So the common factors of 24 and 36 are 1, 2, 3, 4, 6, and 12. Those are the common factors. When I say common factors, those factors are found in both numbers, okay? What about the GCF, or the greatest common factor of 24 and 36? So knowing about the greatest number that can be found in both numbers, okay? So therefore, the GCF of 24 and 36 is equal to 12. All right, let's try another example. Find the greatest common factor of 12 and 24. First, what we're going to do, we'll list down the factors of each number, and then we try to identify the common factors of the numbers. So we have 1, 2, 3, 4, 6, and 12. Okay, so therefore the common factors of 12 and 24 are 1, 2, 3, 4, 6, and 12. And the GCF of 12 and 24 is 12. What about this one? What do you think? Right, we circle the common factors, and the highest or the greatest common factor is 4. Now class, I would like to remind you that if you see this word HCF, it is the same as GCF. The H here stands for the highest, which is the same thing as the greatest. Okay, so it's okay if you meet this word, it's okay, it doesn't matter, it's just the same. Okay, it could be called HCF, or the highest common factor, or GCF, or the greatest common factor. All right, let's go back. So therefore, our greatest common factor of 16 and 20 is... So this time, we're going to solve the greatest common factor using the short division method. Okay, so I think we have learned this one in our previous topic. So what are we going to do? You have to think of prime factors of this given number. For example, we have 16. 16 divided by 2, that is 8, right? 8 divided by 2, that is 4. 4 divided by 2, that is 2. So what are we going to do? We stop there because we aim to have only prime factors. So therefore, the factors of 16, we have 2 times 2 times 2 times 2. Alright, what about 20? Now, we have here 20 divided by 2 equals to 10. And then 10 divided by 2 is equal to 5. So we're going to stop it here. And then we're less than its factors. We have 2 times 2 and times 5. So as you can see here, we have common factors, that is 2 times 2. So therefore, the common factors of 16 and 20 using the long division is 2 times 2 equals to 4. Alright, class? That's all for today. So it's your turn. Follow the instructions and do your best, alright? Bye, everybody.